Dear students, welcome back to Module 5. Today we will discuss Part 7 of the Module 5. So today we will discuss the fourth type of non-preemptive scheduling, that is shortest job first. Okay. So shortest job first scheduling allocates CPU time to the processes based on the execution completion time for the task. Okay. The average waiting time for a given set of processes is minimal in shortest job first scheduling. Okay, so waiting time for the processes is minimal in case of shortest job first scheduling. It is optimal compared to the other non-preemptive scheduling like first come, first serve. Now, what are the drawbacks? A process whose estimated execution completion time is high may not get a chance to execute if more and more processes with least estimated execution time enters the ready queue before the process with the longest estimation execution time starts its execution. Okay, so what happens is, since it is shortest job first scheduling algorithm, if more number of processes with short execution time keeps on entering the ready queue, the process with the longest estimation time or execution time will not get chance for execution. Okay, the process with longest estimated execution time will not get CPU time for execution. Okay, so that is the drawback. Next, it may lead to the starvation of processes with high estimated completion time. So the starvation of processes means this particular scheduling algorithm makes the processes with the longest estimation time wait for a longer time if more number of processes with short estimated execution time keeps on entering the ready queue, right? So this particular situation leads to the starvation of the processes. The processes with a high execution or the long execution time will not get CPU time for the execution. This is called as starvation of process with high estimated completion time. Difficult to know in advance the next shortest process in a ready queue for scheduling, since new process with different estimated execution time keep entering the ready queue at any point of time. Okay, so initially there may be some processes in the ready queue. Okay, assume that the first process is getting executed by the processor. So before moving to the second process, the process with the least estimation time enters the ready queue. Okay, so the estimation time of this new process is very short compared to the remaining processes which are waiting in the ready queue. So in that case, the new process gets the chance for execution. So there is no control over the processes which are entering the ready queue, okay, which are having the shortest execution time. Okay, so that is how it is difficult to know in advance the next shortest process in the ready queue for scheduling, since the new process with a different estimated execution time keep entering the ready queue at any point of time. Okay. So then we will see one example of non-preemptive scheduling, shortest job first scheduling algorithm. Okay. So three processes with process IDs P1, P2, P3 with estimated completion time 10, 5 and 7 milliseconds respectively enters the ready queue together. Calculate the waiting time and turnaround time for each process and the average waiting time and turnaround time, assuming there is no IO waiting for the processes. Okay. Here the scheduler sorts the ready queue based on the shortest estimated time and schedules the process with the least estimated time first and the next least one as second, and so on. So the scheduler schedules in the form of least estimated time process should come first, and the second will be the second process having the next least execution time, and so on. The order in which the processes are scheduled for execution is represented as P2, P3, P1. This is how they are scheduled. So we had P1, P2, P3 entering the ready queue with the estimated completion time or execution time of 10, 5 and 7 millisecond. So process with the least execution time is P2. So P2 comes first, and the next higher execution time is the process P3. So P3 comes next, and the process with the longest estimation time is P1 with 10 millisecond. So P1 comes last. So 5 millisecond, 7 millisecond, 10 millisecond. So the order is P2, P3, P1. P3 has the shortest execution time, and next is for P3, and the next or the highest execution time is for P1. Okay, and these are the waiting times. So P2 don't have to wait in the ready queue because the CPU readily takes it. So the waiting time for P2 is 0, and P3 will wait till the P2 executes its execution. P2 completes its execution. So P2 has the execution time of 5 millisecond. So the waiting time for P3 in the ready queue is 5 millisecond. P1 will wait in the ready queue till the execution of P2 and P3 gets completed. So the execution time of P2 is 5, execution time of P3 is 7. So 5 plus 7 will be 12. Waiting time for P1 will be 12. Okay, 12 millisecond. So these are the waiting times for each processes. These are the execution times for each of the processes. Okay. So same figure is put here also for your reference when you are actually calculating the average execution time and average turnaround time. So first we will calculate the waiting time for all the processes as it is explained earlier. Waiting time for P2 is 0 millisecond because P2 starts executing first. Waiting time for P3 is 5 millisecond because P3 starts executing after completing P2, right? And P2 has the execution time of 5 millisecond. Waiting time for P1 is 12 millisecond. Okay, P1 waits for 12 millisecond. That is the sum of execution time of P2 and P3. That is 5 plus 7, 12 millisecond. Okay, so the reason is P1 starts executing after completing P2 and P3. Average waiting time is equal to the sum of waiting time for all the individual processes divided by the number of processes. So waiting time for P2 plus P3 plus P1 divided by 3, that will be 5.66 milliseconds. Now turnaround time for each process. Turnaround time for P2 is 5 milliseconds, that is time spent in the ready queue plus the execution time. For P2 process, the time spent in the ready queue is 0 plus the execution time of the process is 5. Okay. Turnaround time for process P3 is 12 millisecond. Again, that is the time spent in the ready queue, that is 5 plus time spent in the ready queue is 5, and then the execution time of P3 is 7. 5 plus 7. Turnaround time for P1 is 22 millisecond. That is the time spent in the ready queue by process P1 is 5 plus 7, that is 12, and then the execution time of process P1 is 10 millisecond. So 5 plus 7 will be the time spent in the ready queue plus the execution time of P1 is 10 millisecond. Altogether will be 22 millisecond. Now the average turnaround time is the average of these three. So that will be 13 millisecond. The average execution time is nothing but the sum of execution time of individual processes. So the execution time of P2 is 5, P3 is 7, P1 is 10. So average of these three execution times, that is 5 plus 7 plus 10 divided by 3, that will be 7.33 millisecond. Okay, so the unit is missing here. This is millisecond. We will consider one more example under shortest job first scheduling. Calculate the waiting time and turnaround time for each process and the average waiting time and turnaround time for above example. If a new process P4 with estimated completion time 2 millisecond enters the ready queue after 2 millisecond of execution of P2. Okay, so this is the extension of the same example. We are considering a new process here. So as we have seen in the earlier example, we had the processes P2, P3, P1 with the execution time as 5, 7 and 10, right? So P2, P3, P1 with the execution time 5, 7 and 4. So now what we are assuming is after the completion of 2 millisecond of the execution of P2, a new process enters the ready queue with the shortest time of execution. Okay, and that process is P4. Okay, P4 enters the ready queue with the execution time which is smallest compared to all the execution times, and that is 2 millisecond. Okay, so now we will see how the scheduler organizes these processes for the execution. Okay, as you know, the scheduling is shortest job first. Okay, so P4 enters the queue after P2 is scheduled or P2 starts its execution, and P4 has the shortest time, so it occupies the place before P3 and P1 in the ready queue because it has the execution time which is small compared to P3 and P1. Okay, and it enters the ready queue after P2 is taken up by the scheduler for the execution, so it will take the position after P2 before P3. Okay, so at the beginning there are only three processes P1, P2, P3 available in the ready queue, and shortest job first scheduler picks up the process with the least execution completion time, that is P2 with 5 millisecond for scheduling. The execution sequence will be P2, P3, P1. Okay, so this is the previous case for the previous example. Now, what is the extension? Now the process P4 with estimated execution time P of 2 millisecond enters the ready queue after 2 millisecond of start of execution of P2. Okay, P2 has total execution time of 5 millisecond. After the 2 millisecond of execution of P2, P4 enters the ready queue. After 5 millisecond of scheduling, after 5 millisecond of the execution of P2, P2 terminates and now the scheduler again sorts the ready queue for the process with the least execution time. Okay. After the completion of P2, since the P4 enters the ready queue in between somewhere when P2 was executing, the scheduler once again sorts the ready queue soon after the completion of P2. Okay. Since the execution completion time for P4 is 2 millisecond, it is less than P3 which is 7 millisecond, which was supposed to run after P2 as per ready queue in the previous case. P4 picks up the execution. Due to the arrival of P4, which is having the execution time of 2 millisecond, the ready queue is resorted in the order P2, P4, P3, P1. At the beginning it was P2, P3, P1. Okay, now you might have understood why P4 is placed after P2. Okay, so this particular paragraph explains about, okay, what actually happens when P4 with the shortest execution time enters the ready queue when P2 is already picked up by the processor, and 2 millisecond of its completion is done. Okay, so after the entire completion, that is after 5 millisecond, the scheduler resorts the remaining processes in the ready queue, and then the shortest process takes up the execution next. So P4 is the process having the shortest execution time. So P4 comes first among the remaining processes, then the P3, and the last one is P1. So the calculation, waiting time for P2 is 0 millisecond because it is readily taken up by the processor. It will not wait in the ready queue as that is the first process for the execution. Okay. So waiting time for P2 is 0 millisecond. P2 starts executing first. That is the reason. All the reasons are given in the brackets. Okay. What is the reason behind this particular value here? Waiting time for P4 is 3 millisecond because total time of execution of P2 is 5, but P4 enters after the 2 millisecond of execution of P2. So the remaining time of execution of P2 is 3 millisecond. Only for that duration P4 waits, right? So P4 starts executing after completing P2, but P4 arrived after 2 millisecond of execution of P2. Hence, its waiting time is equal to execution start time minus the arrival time. Execution start time means the total execution time of P2, that is 5, minus the arrival time is after 2 milliseconds, so 2. So total execution time of P2 minus the arrival time of P4, that is 2. So 5 minus 2, that is 3 millisecond. That is the waiting time for process P4. Waiting time for process P3 is 7 millisecond, right? P3 starts executing after completing P2 and P4, right? So 5 plus 2, the execution time of P2 and P4 is 7. Okay, so 7 is the waiting time for, this is the waiting time for P3. Waiting time for P1 is equal to 14 millisecond. That is because P1 starts executing after completing P2, P4 and P3. So waiting time for P1 is the execution time of P2, that is 5, plus the execution time of P4, that is 2, plus the execution time of P3, that is 7. So 5 plus 2 plus 7. Okay, and that is equal to 14 millisecond. This is the waiting time for process P1. Okay, now average waiting time is the sum of waiting times of all these individual processes. So that will be 6 milliseconds. Now the turnaround time for each process, turnaround time is equal to time spent in the ready queue plus the execution time. Time spent in the ready queue is nothing but the waiting time of each process. So turnaround time for process P2 is 5 millisecond, that is time spent in the ready queue is 0 plus the execution time of P2 is 5. Turnaround time for process P4 is 5 millisecond. The time spent in the ready queue for process P4 is 3 millisecond, right? That is execution start time minus arrival time, that is 5 minus 2, that is equal to 3, plus the execution time of process P4 is 2. Okay, so that is added to the waiting time, that is 3. 3 plus 2 will be 5 millisecond. Turnaround time for process P3 is 14 millisecond. Time spent in the ready queue for process P3 is 5 plus 2, that is 7, plus the execution time of P3 is also 7. So this is the time spent in the ready queue. This is the execution time. 7 plus 7 is 14 millisecond. Turnaround time for process P1 is 24 millisecond. That is, the time spent in the ready queue will be 5 plus 2 plus 7. Okay, that will be 14 millisecond. And then the execution time of process P1 is 10. So 14 plus 10 is 24. 24 millisecond will be the turnaround time for process P1. The average turnaround time is equal to turnaround time for all the processes, okay, divided by the number of processes. That will be 5 plus 5 plus 14 plus 24, okay, divided by the number of processes is 4. The answer is 12 millisecond. Okay, that's it for today. Thank you. Any doubts in this particular video, please mail me to my mail ID, which is already sent to you earlier. It is jennifers@stac.ac.in. Okay, JENNIFERS, okay, at sjec.ac.in. Thank you.